This lesson is going to build on our knowledge of area of shapes and take it to talk about surface area of a three-dimensional solid. So in order to do surface area of three-dimensional solid, there's some words we need to know. We need to know first off what a prism is. Now a prism is a three-dimensional object that has parallel and congruent ends. Parallel meaning that they're up and down, they would never intersect, they never touch. Congruent means they're the exact same shape. And then the definition continues by saying that a prism maintains its shape throughout. So if I was to give you two examples, just right here, this is a triangular prism because its ends are both triangles and they're both parallel, they're the exact same shape. The maintaining congruency part means if I was to cut this into like two prisms, I would basically still have the identical sort of shape, just smaller because I cut it in half. So something like a pyramid is not a prism for the simple fact that if we were to cut a pyramid here, we would have a pyramid part on top, but a part on the bottom that has a flat end, no point, so it would no longer be a prism. So this is an example of what a prism is. Now the base of any prism, the stuff written in green, is basically the parallel congruent ends. So the base of a triangular prism are the triangles. Doesn't necessarily mean it has to be sitting on it. It's basically those parallel ends. So if I was to look even at a cylinder, which is kind of like a circular prism, its base is the circle, okay? Or down here as well. These are the bases of this shape. Now the lateral face on any prism is the stuff that's not its base. So on this cylinder, all this stuff around the edge, this is called the lateral face. On a cube, if we were looking, there's the base. The lateral face is all these sides that go around the middle of it, not the top or bottom. Those are called lateral faces. So some information we need to know about prisms. So we'll go down and we'll investigate this. It says, name the following prisms. Now prisms are named after their base. So this right here, the base of this, will make the assumption that it's a square. So this is actually a square prism. Now you probably wouldn't see that often. We would probably say a square prism, the most common name for that is a cube. So it has a special name, but it is still a square prism. In B, we can see the lateral faces around this thing. They're all rectangles, but the base, we said prisms are named after its base. The base is this shape up here, which it's sitting on as well. This is a six-sided shape, so we would call this a hexagonal prism. So it's important to know the names of our polygons. So this is a hexagonal prism. In C, I already mentioned this on top, we name it after the base, but the base is this thing because it's at both ends. So this is a triangular prism. And this last shape would be known on its base it's sitting on. It's sitting on a parallelogram, so we could just call this guy a parallelogram prism. So we name it by the bases. And last here we have a definition that we need to look at. And you've all studied these definitions in the past, or this name in the past, a net. A net is when we take a 3D shape and kind of rip it apart on its edges. So it's ripping apart a three-dimensional solid into a diagram that shows all of its faces. And you've had a lot of practice with this in junior high and even in the elementary grades making some nets. So we're going to look at a pretty complex net on this next page. And it's right here saying if this right pentagonal prism, it's a pentagonal prism because the end of it is 5 sides. So that's a pentagon, that's its base. pentagonal prism was made from one piece of cardboard, what would that piece of cardboard look like? So you have to sit back from this and try to envision how many faces this shape actually has. Well, it has a front and a back that are both pentagons, so that's two faces. And then the rectangles around the edge, well, there's 1, 2, 3, 4 on the back side, and its base. So there's 5 different rectangles on this and the 2 pentagonal ends. So if I was to cut along each one of these edges and try to make a net of this, well, I'd have 5 identical rectangles all attached and 2 of these pentagons. So if I was to draw the net to the best of my ability, I'd say 1, 2, 3, 4, 5. Those would be my identical rectangles, knowing that this is a sketch. So each of them are 30 by 10. And then I need to have those pentagons coming off of here. So when I folded those up, there's one pentagon roughly. And here's another congruent pentagon. So if I was to cut this out of one piece of cardboard and then fold it and tape it together, we would get that shape. So this is simply what a net is. And the most common net that you probably would have seen when you were younger is when we're talking about a cube. So when we look at a cube, it's the same sort of thing. It has 6 faces. We need some squares. Need to make this a little bit more equal. So we got some squares, and then we put the squares off the end. This is what you probably would have seen for a cube in the younger grades. So these are nets, ripping it apart. Now we're going to talk about the surface area. Surface area is simply taking all of the faces of the shape, the solid, and adding them all up. So when we have a prism like the one we see here, the easiest thing to do is to identify, well, how many faces do I actually have on here? I have a front and a back, I got a left and a right side, and I've got a top and a bottom. So that's 6 sides I need to account for. So I would just say, I've got 6 things that I need to find in order for this surface area to be determined. So if I look at the front of the shape, this rectangle, it's a 4.6 by 3.8 rectangle. So the area would be 4.6 times 3.8. You can crunch those numbers and you get 17.48 square meters. The nice thing about this prism is that the back side is exactly the same. So I have another 17.48 meters. Now, to find the third side, I can just look at one of the ends. This end is 1.9 by 3.8. So 1.9 by 3.8 gets me 7.22 square meters. That's that side, but it's also the left end that we really can't see. So another 7.22 square meters. Now the 5th and 6th sides will come from the top and bottom. So the bottom of this shape is another rectangle. It's 4.6 by 1.9. 4.6 times 1.9 will tell me the area of the bottom, which is 8.74 square meters. And again, that's the side across from it as well. So now that's all of the faces of this shape. So the surface area is just the sum or adding all of these up. So if we add up all of those sides, we get 49.4 square centimeters for the surface area of this rectangular prism. Now we're going to move down to this more complex figure. Although it's a whole bunch of rectangles, we need to now find the surface area of here. The number of faces isn't as easy to see. So we're going to start labeling these, and we're going to start finding out which ones we need to work with. So if I look, I do have this left side. This left end is a rectangle. It's 55 centimeters tall, and over here you can see it's 27 centimeters wide. So if I look at the end, that would mean I'd have 55 centimeters tall by the 27 centimeters wide for the rectangle. That's 1,485 square units. Now that's this end. But consider this side that I'm going to shade. This area and this area, if I was to shove those together, would be the same size as that other end. So I can say, you know what, I have another side that's exactly like it, 1485. The area of this shape and this shape together would be the area of the left side. So I've got my ends taken care of. Now let's look at the bottom. The bottom of this shape is just a very large rectangle. It's 78 centimeters by 27 centimeters. So if I crunch those numbers, I get 2106 square units. And in our case, we're talking square centimeters. So 2106 square centimeters, that's the rectangle on the bottom. But again, if I considered this side that I'm shading and this side that I'm shading, that would cover the same amount of area as the bottom. So rather than going and finding those two pieces separately, we can just say, you know what, I know that that's also 2,106 square centimeters. Now, the last pieces that we need to find are basically the front and the back of this shape. Now, the front and the back are a little bit more complex. They're what we call a composite shape, kind of like what we talked about in our last lesson. We know that this is 55, this is 78, and we've got a 30. Again, not drawn too well to scale. But we have a rectangle down below that we can call area 1. And then if I came across here, I have this piece here that I could call area 2. The problem being is I don't know what this distance is or what this distance is. But I have enough information from my shape to figure it out. If all the way across the bottom was 78, and I neglected to put this little bit here at 45 from our diagram, and this is 45 from right up here, we could see that this side has to be 78 minus 45, which gets us 33. And then likewise, this chunk right here is just going to be the difference between 55 and this 30. So that means that side is going to be 25. So now we have, for the front, two rectangles that I could be looking at. So the two rectangles that we'd consider is the big one at the bottom, that's 78 by 30. So 78 by 30 gives me 2,340. So that's this shape all here. It's 78 by 30. Now I need that little rectangle on top that we just determined was 25 by 33. So 25 by 33 gets me 825 square centimeters. So that's the front of the shape. But if I consider the back of this shape, nice thing, it's the exact same size. So I'd have another big rectangle that's 2340, and I'd have another smaller one on top that's 825. So now I went through and I found all of the faces of this composite shape. So the question's asking us to find the surface area. The surface area is the sum of this entire column. So if we add up all of those values, we have the surface area of this whole shape being 13,512 square centimeters. And we accounted for all of its faces. The last question has quite a bit of reading, and it is a problem-solving question involving surface area. So we have a guy that's been hired to paint the walls and ceiling of a living room. The room is 22.5 feet by 13.5 feet wide, 8.5 feet high. It talks about one window that's a certain size, two windows that are another size, and and two doors that are a different size. It says, what surface area must you paint? Well, we have to step back and think, okay, first off, I need to see what this room looks like. And I have to consider that I don't paint windows or doors. It's just the walls and the ceilings that the question says. So we'll start with a diagram. And we're saying this is what our room simplistically looks like. Okay, it's just a box. And it says it's 22.5 feet long, 13.5 feet wide, 8.5 feet tall. We'll concern ourselves with the walls, or sorry, the windows and doors here in a minute. Let's just figure out if there was no windows or doors and we are painting the ceiling as well, what would our surface area actually be of just this, excluded with the windows and doors just being full pieces? So we're going to look at first, we've got this wall here. This wall is 22.5 by 13.5. Oh, my apologies. That's 22.5 by 8.5. It's 8.5 feet tall. So if I was to figure out what that one big wall is, it's 191.25 square feet. Likewise, the back wall is also 191.25. Now the ends, these walls, are 13.5 feet by 8.5 feet tall. So that would give me 114.75 square feet there. The only other piece that we're missing is the actual ceiling. Now the ceiling's right here, and that's the same as just the bottom, but we're not painting the floor, so it's just going to be 22.5 times 13.5, which gives us 303.75 square feet. Now, all of this together would determine our surface area. So if we were to add up that would be the four walls and the ceiling. That's 915.75 square feet. So we're going to use that number here for some more calculations. Now, what we have to do is actually consider things that we aren't going to paint. Now, we're not going to paint the windows or the doors. So the question does say that there's one window that's 10.5 by 6 feet. So 10.5 by 6 feet gives me 63 square feet. Then there's two other windows that are 3.5 by 2.5. So that gives me 8.75, and it does say there's two of those windows. Then the other things the question says we don't paint are the actual doors. So the doors are 2.5 feet wide by 8 feet tall, and that gives me 20 square feet for both doors. So this stuff that I'm writing in green is stuff that we don't need to paint. So it does not require paint. But we got to consider, well, how much are we not painting? So this total, or the sum of this, is 120.5 or 120.5 square feet that does not require paint. So now when we look at the question saying, well, how much surface area does this guy actually need to paint? Well, his surface area is saying, well, if I just took the 915.75, which is saying there's no windows or doors in this room, take away the area of those windows and doors, which we just found to be 120.5, that would tell me that he has 795.25 square feet that he needs to paint. So that's the answer just to part A, saying how much surface area does he have to paint? Well, we figured it out to be 795.25. Now question B says, well, he went to the store and he reads on the can that 1 can or 1 gallon of paint covers 255 square feet. How many gallons does he need to buy? So part B then, we just say, well, if he needs to paint 795.25 square feet, but each can only covers 255 square feet, and it's sold in 1 gallon cans, if you divide this out, you see that's 3.11 gallons. But there's a problem with that. When you go to the store, you either need to buy 3 gallons or you need to buy 4 gallons. So this means that because he needs a little bit more than 3 gallons, he actually needs to buy 4 gallons of paint to make sure he has enough. So he needs 4 gallons of paint. Now the last part of this question is saying, well, it's $55.40 per gallon. And then he still wants to make 225 bucks profit. So he wants to add $225 to the final cost. So he's making some money painting this room. So how much does it actually cost him? So 55.40 per gallon. So we're going to go back and we're going to say, well, part C, he has 4 gallons, and each gallon is $55.40. So just for the paint, he needs to pay $221.60 just in paint. But he wants to charge that back to the person he's painting the room, and he wants to make $225 profit. He wants to make $225. So he first has to take that $221 and charge it to the person he's painting for, and add another 200. Sorry, I forgot what the number was. $225. So the total cost to the person he's been hired to paint the room for now is going to be $446.60. So he's going to end up charging that to the person to recover the cost of paint and to get $225 into his pocket.